In 5A, we're looking at Le Chatelier's principle. This could go in free response as a part of a long or short question. It could be in multiple choice in a group of questions or even as a standalone. As we look at this and all equilibrium questions, we look at the states of our reactants and products. We look at the coefficients on our reactants and products. And then we are carefully thinking about how changes in anything would affect it. So on the initial stress, because of Le Chatelier's principle, we're looking at a change in how that causes the equilibrium to respond. The stress is the addition of carbon monoxide. Carbon monoxide is a product and carbon monoxide is a gas. So now I have too much of this. From a K sense, we can think of that as being on top of the equation or on the numerator, and having a larger amount of that would then throw our K off, making it too big. Or we can think of it from a reaction sense. I have too much of something on the product side relative to what I had at equilibrium. The reaction needs to use that extra amount. It would shift left, making more of both reactants. It would consume the extra carbon monoxide, and it would also consume some of the arsenic gas because I need both of these things in order to make more reactants. So I would use the extra, but I would also use some of the AS4 that was there. The addition or removal of carbon. Initially, we would think, okay, carbon's right here. How is it asking about two opposite things? And then when we focus in on the state of matter, that's how we know. Adding more of a solid or removing some of the solid does not change its concentration or its pressure. Therefore, it does not shift the equilibrium. So changing solids and changing liquids does not change their concentration. Therefore, does not shift equilibrium. Removing something. In this case, the arsenic gas. I had some, I took it away. In this case, it was a product. I need to get some of that back. At equilibrium, there should be a certain amount of every reactant and product based upon the value of K. When something is removed, we have to make more of it. That would mean that we would shift right to create it. In doing so, our two solid reactants would be consumed slightly, and we would make more of the arsenic gas. And in doing so, we would also make some more of the CO, and then we would be able to get back to that same value of K. When I change the volume or pressure of the container, I need to focus in on the things that are gases. So sometimes we have what we call a heterogeneous equilibrium, solid, liquid, gas, and maybe even aqueous. For those, we are very much focusing on the states. When we are looking at volume and pressure, we are only focusing on the gases. In this case, we have no gas on the left side, so relatively speaking, our reactants take up very, very little to no volume. We have a lot of gases on the right side. The arsenic and the carbon monoxide particles are very far apart, moving very quickly, and take up a lot of space. When I increase the volume of the container, it shifts towards the side that has more molecules or more moles of gas. There's no gas on the left, there's a whole bunch on the right, so it shifts towards that side on the right. When I decrease the pressure, that is the opposite there. That's kind of like rather than squeezing it together with a high pressure, we are easing that pressure off or allowing the molecules to kind of expand or spread out. That's the same thing or similar with Boyle's law to increasing the volume. A high volume and a low pressure will favor the side with the most moles of gas. The math that proves this with Kp and Kc is quite more confusing than any math that we have done with this. So really just focus in on counting your moles of gas, which side has more or less, and if they're equal or if there's no gases, that's going to cause no shift.